everybody for new features in RISA. We're really excited here about our new release, and I wanted to talk about the 4 programs in particular that we're going to be releasing: RISA 3D version 10.0, RISAFloor version 6.0, RISAFoundation version 4.0, and RISAConnection version 2.0. So these will all be coming out. If you're not familiar with some of these programs, we'll have a brief chance to take a look at the new features in particular, but we'll also look a little bit around the software too. And one thing, what happens is that we release all the software together, these 4 core programs. And the reason being is because they do communicate with each other. So it's important that they all get released together so the versioning is the same there. So you'll see that these are all correlating and as we go forward. So let's see some things that we're going to talk about in this is all our new features that we're going to be adding to all the programs. There are some overlapping features, and codes are one of the things that overlaps. So I'll talk about some of the new codes that are going into the program. In the AISC 14th edition, also 360-2010 Steel Code. This has been added into the program, and you'll see we'll talk a little bit about that as we go forward. But we also will be offering a webinar specifically on that code on April 10th. So if you are interested in learning more about how that code was implemented, you can take a closer look at that webinar coming up. We've also added Canadian cold form steel for 04 and 07. We've had some of the codes in the past year, but this is the latest and greatest. We've also added the ACI 318 2011 for the concrete design, and we'll see it in action today with some of our concrete features. We've also added the ASC 7 2010 seismic and wind loading. So we'll also see some of that loading in how it changed a little bit from what we've got in the past. So these are going to go across multiple programs, but specifically, if we look at what happened in some specific programs, RISAFloor has a lot of big features, and we're going to talk about here today is some live load skip loading for columns that were added inside of RISAFloor. So if you're not familiar with what live load skip loading is, that would be where we're applying dead loads to the columns, and then we are alternating the live loads that get added to the column so that you might induce a little bit of eccentricity or moment in that column. And we can see that we apply that into the program. The other thing is that we've got, goes hand in hand with live load skip loading, is an automatic inclusion for connection eccentricity for columns. Now, that one's automatically done for some raw and steel members. You'll see that as we draw members in there, they're going to automatically have that eccentricity in there. We also can enhance that by applying some connection rules so that we even back off the eccentricity farther to account for the connections. But we'll see that, for example, a beam would frame into the flange of a column, and we're going to set off by a rigid link. So this is a newer feature to RISAFloor. In RISA 3D, you might be familiar with rigid end offset. This is very similar to that, but it's a little bit more automatic in RISAFloor. In RISAFloor, we also added a deck database. So we can specify per manufacturers for composite decks and metal decks, and then we'll also see we changed the format a little bit to make it a little bit clearer for how to apply a deck inside of RISAFloor. It's a great new interface. We also did, by high demand, we added copy tools to the floor framing. We not only added copy tools to RISAFloor, but we enhanced what we had previously. So we'll see that there's many different ways to copy the framing in RISAFloor, and we'll go through some of the examples of that. And we also did the same exact enhancements in RISA 3D. So what we do in RISAFloor, we'll also see that also applies to RISA 3D's copy tools. 3D specific big feature that we added is that we had, and you can see a picture on the right side here, is that openings to concrete wall panels. So we've had wall panels in RISA 3D for a couple of years now. We had masonry walls, we've had wood walls, and both with openings. Concrete walls were added about a year ago, and now you can add openings inside of that concrete wall panel and get reinforcement design. And it's a big one, we'll see that, as well as hydrostatic loading for circular tanks. So with inside of the generation tools, you can apply some hydrostatic loads. This is useful for circular tanks. Obviously, that would be when you would want to have some of that that loading there like that. We've also, as I mentioned in the last slide, we have copy offset tools that were added directly into RISA 3D, and we'll see that a little bit closer. That's a great tool and something that folks have been asking for a long time, so I'm happy to show you that one. Foundation, some of the big features that got added into RISAFoundation, you can see on the right side here is retaining walls. So we've got a picture here, and we're going to go into a lot more detail once we get into RISAFoundation. But you can see we've got a wall propped up with some structures behind it, and we'll go into some examples and draw in some retaining walls and see some results there. Also added the optimization of footings for uplift and overturning and sliding. So in the past, you've had footings, and it would give you a warning whether you were actually getting some uplift or overturning. It would give you some ideas that how you were failing, but now we're going to actually optimize that for you. So that's the big features in RISAFoundation. So in RISAConnection here, we've got some bigger features. RISAConnection is a little bit of a younger program, so you've got a lot of features added into RISAConnection. Specifically, we can see on the picture on the right, that's the vertical brace connection design that was added in there. We're going to be able to do a chevron brace as well as a diagonal brace right inside of RISAConnection. We can look at some of the examples there. We also have column and beam splice connections. So we can do shear and moment connections for column and beams. We also have added axial loads included into connection design. So you've had moment and shear. Now you're going to see axial loads coming through. This is in particular the most important piece when it comes from RISA 3D or RISAFloor. If there are any axial loads, that will automatically be brought RISAConnection for you. We also added DXF export of the connection details. So in particular, when you're looking at the two-dimensional pictures in RISAConnection, all of those can be exported directly into your DXF format, so you can prepare your construction drawings directly from that. We'll see an example of that too. That was kind of a long list of the different things we'll be looking at, but actually show you these features in action. So let me jump right into the program. I'm going to go into RISAFloor. So I built a model so that we can take a look at the features more in depth rather than actual modeling. And in RISAFloor here, this is a three-story building that I put together. Just want to take a quick perusal of the actual model. What you can see here is that it's just basically a steel model, a steel building frame with some concrete shear walls. And if I just double-click on a concrete wall, we can see here, this one's just a single-story. I have a couple walls in here with some openings, and we can see that those concrete shear walls here have some window openings, 3 floors. I'm going to open up this one here. This has a door on this side here. Now, if you're not familiar with RISAFloor, one thing is a little bit different viewing than we look at in RISA 3D. We can look at the full model view, which we did here for a sec. This is the full three-dimensional model. But we also have this tool here at the left side that helps us look floor by floor. So I'm looking at the first floor, maybe second floor, and third floor. So it helps us look at the model directly in plan view. Now, when we look at this model, we are seeing things in blue and red, the two different colors, what's part of the real model and what's part of the gravity model. So when the red ports are maybe our moment frames or brace frames here, and I have a couple of each in this model, and we see our shear in red, and the blue beams are noted as wide flange. Now that's another distinction between RISAFloor and RISA 3D. RISAFloor is going to design these members. So start at the bat, we give it a design list or a wide flange shape list instead of telling the program specifically what type of wide flange to be using. So explicitly calling out the member. I'm going to jump to the second floor. You might have noticed I have a little hole in my framing. What I wanted to do here was to use some of my copy tools to help show you how this copy tool was implemented and how it will help you. So let's see. I'm looking at the second floor. I'm going to turn on my graphical toolbar here, and I'm going to zoom in. Now, the copy tool works on what's selected in the model. So I'm going to just copy some of this framing. I'm going to unselect everything in my model and just select one piece of that, one beam in here. And I go to my copy tool. It looks a little different than it has in the past in RISA 3D. We see a little bit of different interface. And the first one in particular says we can copy by location. So what it is we can click from one point to another point to define the distance. So I'll copy the selected beam I have here. And I'm just going to say apply. and I'm going to click on a point. I could have clicked any point I want, but I'm going to click on the side of this this one beam, and I'm going to another point. So I see it's trying to determine a distance for me. So I click to a point, and the beam gets copied. Kind of can do it. I can keep doing that by clicking point to point, and it will keep clicking and copying that location for me. That's one method to do this. Point to point helps you define it that way. I can also do it by increments. So what I'm going to do is unselect everything, and I'm going to show you some increments. So I can click on that copy button one more time, and I'm going to choose increments this time. Now tell the program I want to go in the Z direction for this beam. I can maybe, let's say these are 8-foot spacing typically. Let's do an odd spacing, maybe 7.5. And then apply, and it copies that 7.5 feet over. What I'm also going to do is I can actually do some math there. So I can tell the program that I want to do 7.5, but I do it several times as in an array. So I can tell the program, let's do 2 spacings at 7.5. So do that as an array, and I can say apply, and it will copy that over as an array. So it's a little different there. It'll let you do that math in there, not just a single value. I'm going to clear that out. You can also do angles, so you can tell the program to copy something off in a different angle. I don't have a great example of that because this model's finished, but what we'll do is let's just copy something just so we can see. We'll undo it after the fact. But we can copy this maybe 45 degrees, and we can copy off by 10 feet in that offset. So this column that I just selected can be copied off by 45 degrees and 10 feet. Now it's going to ask me, do I want to copy the entire column stack? And I'll say, sure, let's do that. And we can see that it copied it in 45 degrees. So it'll sort of do that different direction. Do that because that wasn't really what we want there. The other tool, though, so we did out our framing, and we have a little odd spacing, but that's going to be sort of what some odd dimensions that we might have needed. The other tools that we can do is we can use copy offset. So use that tool right now. It's right next to the copy button. It's something that says copy offset, and this, let's see here, allows us to copy a member by a certain perpendicular increment. So this is kind of similar to what you might have seen in a CAD drawing format where you can offset a beam. Here, let's see, I'm going to offset this beam by 5 feet. So if I click on apply, I can actually offset, maybe we'll make a balcony like this. So I can offset it, and as I click on that beam, my cursor changes to a point, and it tells me at the bottom, select a side of the beam to offset. So do I want to go interior? I'm going to go exterior because that's a balcony. So I'm going to go out there, and you see that that member actually offsets by 5 feet. I can do the same thing again on this my balcony. I'm going to go out by 5 feet. So it helps me lay out sort of things by offsetting versus copying, and it's just going to go perpendicular to the location there. So this is also available in RISA 3D. What now is I'm going to just extend some of these members out so we can actually frame this a little bit. Go and give myself a cantilever, a 5-foot cantilever on each of these members just to frame out there. Let's see here. Zoom out. I'm just going to undo that for a sec, make sure okay. So we're going to cantilever that out, and the offsets here, we see it cantilever right out there, so I can match up with those balcony beams. And now the slab, what you'll see there is it's kind of overlapping, and that's not what we want. So what I'll do is I'll delete my slab edge, and I'll redraw it. So I'm going to delete that, and I'm going to just draw that slab edge one time right on those cantilever beams. When I talk about the slab edge, this is a good time to talk about the deck. In particular, we talk about slabs and decks in sort of the same way. We talk about the slab edge, which is synonymous with the actual diagram. So the trim edge is going around the building there. But we also assume that there's a default deck happening in this model. So that deck helps us distribute the loads directionally. And if I look at the floor spreadsheet, it tells me on this second floor, which is where we're looking at right now, the second floor has composite deck. Now I mentioned that we rehauled the deck database, so let me show you how that looks. So if we go back to the deck definitions, it tells us here that that composite deck is a Verco deck, and it's a form lock deck there. And let's take, so you might recognize some of these if you're familiar with RISAFloor, flat slab, composite deck, metal deck, wood. And these are the similar names that we've used in the past. But what you'll notice here is when we click into this material type, there's that little red arrow that shows us there's a little bit more information. So if I expand on that Verco deck, it gives me a library of different decks. And I can pick from this different library. So this is something that's right outside the program. So I can save these. These are a spreadsheet basically outside the program. So I can bring in whatever database I want. Let's take, I'm going to use maybe the 4-inch nominal weight, normal weight, 22 gauge there. I can define my studs in here. I can tell the program whether these are short. This is going to be a short deck or not. I'm going to change my material. It's going to be, let's say, 4,000 normal weight. And I can say OK, and it will tell all that information mimicked right here for us. The self weight is automatically calculated based on that composite deck, and you can see here that it's listed out for us here. So that's for the composite deck. I also have different deck properties for my metal deck. I have a library of different shapes, so I can choose through my pick one that might work for me, and go from there. Maybe use a B deck there. Say OK, and I'll see that it's listed there for us. So those two types of this new interface is a great tool for you to be able to find some deck information. The flat slab and the wood decks are not really that different. If we click on that, all you tell the program is specifically how thick that is. If it's a 6-inch there, slab, and then you can tell the program what type of material you're using and say OK, and that will also be listed under your self weights listed, calculated automatically for you. Wood is very similar to that, where you just give it a thickness in inches, and it'll calculate the wood density for you. So all of your deck information is kind of condensed in that nice dialog box, and you can open up models from the past, and you'll see the very similar information there. You can assign some decks there. The difference, the commonality in this deck database is that you can define your unbraced length and your max span. Otherwise, all the other information is going to be right at that material type, and the loads also can be defined on the second tab. Nice dialogue that will help you hopefully clean up your decks a little bit. So what is, let me close this down. And we've got, after I look at my decks, is I'm going to run this model a little bit because we have a deck defined around this, and that was what we said was the composite deck. And it's going to run through the solution here and solve this model. It's now designing each one of our members. So you can see at the bottom there it's iterating between the solution. And a bit about here that eccentric. The next step is to talk about how we actually see that each member is framing in eccentrically and being held off based on its eccentricity, on its connection there. So hang on, we're almost done with solution, and I'm going to close this out. So let me zoom a little bit. And what you see now is that we've got, I'm going to just take a look at this corner in particular. It's kind of a nice compact corner, and we can see that each of our members was designed. So now we have a W12 by 26 for a lot of these with 14 studs, and we're seeing some framing. This is going to be a moment frame, so we see moment at the end of this one here. What I want to show you is that if I turn on that column eccentricity, now it's not typical to view it with the pin connections in in RISAFloor, but if I zoom in, you can see there's these little circles that are very similar to RISA 3D where you see that pin connection. And now the pin connection ties right into the beams themselves, but where the column frames into the flange, you can see a little grayed out, what we call a rigid link or a rigid end offset that's holding that connection off of the edge of the center line by the depth of the member of the column there. So you can see that's actually showing us that eccentricity is going right into that member. We also notice here it does not happen on this one because we're framing right into the middle of the web. So there's no holdback, or there's no distance that we need to hold the beam back by. It is happening on the left side of this column though, with that little gray mark there. That it's a little bit hard to see, but if you look at what you can really indicate it by is this little circle. That pin connection is happening at the face rather than at the actual center line. And with that type of connection, all the model you're going to see these little gray lines doing that for you automatically. All of the things you can do is as we define connection rules. So we're going to be taking this model over to RISAConnection. I'm going to show you here that we have some connection rules defined. I'm going to look at here. So if I open up my connection rules, in all, when you design a model in RISAFloor or RISA 3D, you have some connection rules assigned for different things, column to beam connections, girder to beam connections. Now, you have to then tell the program where you want these connections to be placed. But one of the new items in here is the eccentricity. So go hand in hand with the beam to column connections. Also can hold back based on the connection type there. So this clip angle is going to be held back by 1.5 inches to account for this connection of the clip angle. So let's see. I've actually assigned some of these connections. Let me put the connection rule on my model. So if we zoom in a little bit, I just put a column to beam clip angle on this connection right here. And so we can see that if I show, for this one, if I show the column eccentricity and zoom in a little bit, it shows that it's not only at the face, it's also held up by 1.5 inches. So this also ties in with that. So you've got connection rules defined in there as well. You'll see if you did any shear tabs, that would be 3 inches. So it gives us the ability to do that all together. Now, the other piece that I mentioned is that we do column skip loading. And so something that we can view, let me look at a detail report. That's probably the best way to view this. So if I click detail report for a column, what I'm at is the forces through the column. I'm seeing a little bit of moment here. I'm going to turn this to the dead load and live load cases, and I see a little bit of moment in there, which is kind of that little eccentricity going into this model. And I scroll down here. This is your typical detail report. Gives us a summation of the forces and the point loads and all the different stresses, and then the code check information, the shear and the moment calculation. So very lightly stressed column we can see. But what we do see at the bottom here is our column skip loading, and this is the new feature added. And what you can see is that for a column skip loading, the column is broken into 4 different connections there, or what we call quadrants. And so each portion of that column is loaded in many combinations. The dead load is always there, okay? But the live load, which also in this note includes roof live loads, snow loads, any other thing that can consider not a dead load, is then in combination put together with the different sides of the column. So the column in particular, the one that controlled for the bending, shows us that it was L1, which is this portion here, L2, and L4. So it would be L3 in place. And we see if we look at that, we zoom in on this column. So without this beam connection, with these 3 load connections tied in there, it would be the worst case for this column. So we actually do a pan loading, and you can see that it's doing that. It's showing us the controlling pattern. So floor, walk through that for each one of your designs there. You can see the detail report. Some of the ones we might see, let's see here, where we are actually seeing a little bit different, maybe the sort of L1, 2, and 4. So again, was very similar in this section of the building. So that's the big features here in RISAFloor. I want to also take this model right into RISA 3D. So once done design in this model, I've got a complete design here. I can director over to RISA 3D. So go to the top right corner, I click on the director button, and I go to RISA 3D. And in RISA 3D, what we're doing is a lateral design. So right here, it starts to ask me what lateral design I want to do, and it asks me the parameters of that. So it looks like here I have selected the ASC 710, which is the newer code that we just added. And the big thing you'll notice from ASC 705 to 10, really, the very largest thing is that there's no occupancy category. So that was a very confusing thing. I don't know if people ever get that, but with the occupancy category 1, actually did give you an importance category of 0.85. So a little strange. But if you actually go to 2, that was an occupancy category, gave you importance category of 1. So they took that out. I'm glad. That was a little bit confusing. So you can calculate the loads this way, and it's a little bit easier to understand. And then this is all of your wind forces that are generated per floor level. So we have all that in place. I'm going to also say OK. I'm going to pop over to the seismic. Seismic here, we have ASU 7 2010. I put some parameters in here automatically, so we at least have something here. I think this looks like we are design category B. So I've listed out here. Now the bigger feature that was added here too, as well as the code, is that we have totals at the bottom there. You can see the total seismic weight. you can see forces in the different directions. So it's a nice, quick, easy way, almost a back of the envelope. Hey, does that number look right? This is kind of the biggest way I always look at that. I've had lots of folks in practice tell me, I actually calculate it out and it doesn't seem right. So that's a quick, easy way to know that. Does my building really, should that be about 4,000 kips? So I like that feature a lot. I can push OK and hop over to RISA 3D. Now in RISA 3D, only the portions of the model came across, and so you'll see here I've got my walls with my moment frames and my brace frames, and I've got my concrete shear walls in place. You can see the openings came across there. We can look at, let's double check here on our codes, using the 14th edition for my code. Now, an important piece, the only interface change that you'll notice for the 14th edition is the erased links. So if I double click on a member, this is, if I go over to the design tab on this, you'll see that everything is the LBYY, LBZZ is as it was, but there's an L torque. So if you're lateral torsional buckling, if anything is going to go that, you define that L torque value there. So and we'll have a webinar specifically explaining how these things have changed, but this would be your only change for the 14th edition. So let's see here. The other thing I wanted to talk about, make sure that you saw inside of RISA 3D, the copy tools are very similar to what we just saw in RISAFloor. We can do copy point to point. We can do by increments. It allows us to do increments. Now, another piece in the increments is we can actually do these increments on angle. So that's a little different than the way you used to be able to do it in RISA 3D. If you wanted to go in an angle, you had to copy and move. Now, actually, we can just copy in an angle. So if I have two directionals here, and I might just let me throw down a beam on my, so we can actually just see how it works. I'm just good for reference. If we put a beam there in our plan view, when looking at this here, let's see, where did mine go? There we go. So if I just look at this beam in particular, I can copy it in an angle, and I'm going to show you that for a sec here. So if we copy, and I have two directions here, so it's in the X and in the Z direction. I'm going to copy it in both those ways, and I say use increment simultaneously to perform a skewed copy. It will copy it in an angle. So that's a nice way to make that change a little bit more user-friendly if you want to do an angle in any way. The other thing you can do is offset that. Just like we did in RISAFloor, you can use this offset tool right there, and I can choose to offset it maybe perpendicularly. I can do it in the global or the local axis. Now that's huge because a lot of times if you're building a truss, for example, even in a braced frame situation, maybe you need to offset something. The local axis is really going to be very helpful. So let's take a look. This will also just be for example, but if we look at this map and we turn its local axis, we can see that its local axis in the local y direction. We can offset that in the local y direction, so offset it by 5 feet, and we can see it kind of goes up in that 5 feet direction. So instead of using just the global axis, it'll help us do that offset tool. Very useful, again, if you're using stuff that is on the wall. So I'm going to delete that out of there. Model here, let me turn off my local axis so we can see a little bit better. In the model, what I've gone ahead and done is I've placed some braces in and some braces in this middle. I've got some moment frames are already defined. We also talked about the openings in this concrete shear wall. So let's just review that for a second. If you're not familiar with the wall design, the concrete wall design gets defined right inside of what we have as wall design rules. So if I pop over into now concrete wall design rules, this is where we lay out the reinforcement design. So I had the vertical bracing. I tell the program what the minimum and the maximum spacing should be. I tell the bar size increments. So go start at the minimum will be 4, the max will be 18. So go from 18 down to 16, down 2 to 14 until it works all the way down to 4 inches. So we've also got the horizontal spacing, minimum and maximum with the increments, and I can group different walls together if I want to group them with the same reinforcement pattern. I have concrete walls design, so I can tell the program to do each or centered for the reinforcement, where to put the vertical bars, have my cover information and whether I want to transfer loads in and out of plane. So this is where you define all your reinforcement. I'm going to run the solution really fast here, and we'll see. Let's take a look at some of the results once we have that in place. So I'm running a solution that I created here just from some of our P deltas on. That should be okay for now. A solution based on some of my different load combinations that were created. So again, if you're not from the RISAFloor to RISA 3D, it does loading for you automatically. It puts in the wind loads, it puts in the earthquake loads, and then I can easily apply them directly based on that we talked about was automatically placed, and that diaphragm is doing the design here. So it helps us to distribute that diaphragm. So we can see those point loads are being applied when I apply that. What to do is our load combinations. So when I'm looking at the middle, let's take a look at some of the information that we've got for that opening. So if I look here, I'm going to open up this wall in particular. This one has an opening of a door opening. And it gives me the solution based on all the different pieces of this. It tells me what my input really was. And as I scroll down, it gives me some information based on unity checks for each region. Okay, so we're doing like a region-based design here. And it tells us the unity check for input out of plane. It tells us the reinforcement results. Also, we can go into each region and look a little further and see what was happening in that region in particular, maybe in plane and out of plane. And we see that we've got our interaction diagram, and let's just jump to out of plane really fast. And we can see this one is a little bit, gives us the interior and exterior interaction diagrams. It also gives us the reinforcement showing, described as like more of a detailed section. That is also available in our results. If we look at panel design, it gives us a breakdown of each wall's region. It tells us the load combination that governed, tells us unity checks, shear checks, and this is a way just to kind of run through your really see how things did. Maybe you need to size things down or up depending on how things are. These unity checks are very low, so we have too much reinforcement, or maybe we're just hitting the minimum, so you have to kind of go from there. The other thing here, we've got the detail reports we look at. We can also look at just looking up that wall panel editor. So this is kind of a nice way to see the reinforcement on each portion of that wall. We've looked at that a lot. Let's look at this wall. This one has openings in this direction. So we see here that you've got each region is detailed out for you and gives you the different reinforcement in a really great picture format there for you. You can kind of zoom a little bit to see that. The reinforcement is listed in several different spots, and you can see which one is useful for you to actually there for your reporting. So concrete walls with openings. Let's take the model over to RISAFoundation and view that. So with the solution present, now I have both my lateral design done. I have also my my lateral design, seismic and wind, as well as my gravity design. And I can take this whole model over to RISAFoundation. So the director button at the top right corner, and there's RISAFoundation is now listed there. And I'm going to pop over, and all the loads that came in from both RISAFloor and RISA 3D are here for me. So I can flip through loads and just double check. Let me turn load labels off so we can see. I'm going to look at this in isometric view. So what is I put some footings in here because I really want to demonstrate the retaining wall feature. So I already laid out a little bit of this foundation for myself, but what you can see is that all loads come across right as they were. So dead loads are coming across directly from RISAFloor and RISA 3D. So they come in as categories, so they tell us the different stories here that we've had, whether we had wind load in the X direction. Let's jump to that. We can see the different loads that are applied there. You'll notice that it's less because this is only the portion of the RISA 3 model that has wind load on it. That was the lateral system of it. And we can wind load in the X and the Z direction, the X direction. We can also look at any of the earthquake loads. So all applied to our model. We're ready once we've got our loads in place. So we see that our dead loads are there. I'm going to look at this back in plan view, and then we're just going to turn off those loads for a second, so we can really see the footprint of this building. So what we can do is lay out. We have footings for the interior, and I would assume that would be kind of our interior supports. What I want to do is look at my retaining walls. So are also held inside of the entry toolbar. You'll see there's a retaining wall definitions. That. What I have here is a spreadsheet spreadsheet format of the different pieces of these retaining walls. So I defined an exterior and an interior, and let's just open this up. So spreadsheets can be great ways to quickly change numbers. What I also love on this feature is if I click on this little red arrow, it opens up more of a pictorial format for me. So it really helps me understand. There's a lot of input in this type of retaining wall entry, so it's helpful for me to understand what I'm looking at. And what you'll notice if I click anywhere in any of these different entries, that I have a description in the status bar right here. So if I click on this H wall, hey, what is this wall? You know, it's drawn for me obviously, but it can be hard with some of the descriptors to see what we're looking at. It will tell us a little bit more information. So we've got here this wall in particular is an exterior wall, and it is not propped. We're telling the program that there's nothing going to be resisting in the other direction, like we're going to actually let it be a cantilevered retaining wall versus a non-cantilevered retaining wall. We can give it the thickness here. If we want the toe here or the heel, length as depth. So the footing depth right here is 18 inches. We can tell the program how tall the soil is. So right now our wall is 14 feet high and our soil is 12 feet behind it. We can give how the saturated water level is going to be behind the wall. So that's all my geometry. You can go through each one. If I'm going to put dowels, we're going to do one layer of dowel, 2 layers of dowel. This is all the entry for we can put a key in. Well, it looks like I have left this as the key, so there's going to be no key in this wall. If I go over to the soil pressures and information, I can put surcharge on this wall here. So I can tell the program that there's going to be a little surcharge in that. I also can tell the program in here what the different information for the soil is behind the wall, the saturated soil versus the non-saturated soil. The cat there is the earth pressure coefficient, and it will automatically be calculated for you based on the information you give in here for your gamma, so your unit weight there, going back to geotechnical stuff. So you kind of enter that stuff right in there. You don't have to define the K-lat for yourself there, but you also can define different for the toe versus the heel, so you can have 2 different soil properties in there. T-bar reinforcement here, we can see it's out, shows us what was going to be in the actual portion of it versus what's going to be in the footing portion. So this upper portion here tells us what's in the wall. We can do each face, we can do single layer. So 1, 2 layers. If we go to single layer, it's just going to warn us, hey, you're going to change to 1 layer for your dowels. And we say, okay. I'll bump it back, but we want that you can do both each face or single layer. I'm going to go back to each face. I think this one's going to require that we have each face. Maybe change the horizontal bar spacing. We can program what the cover should be, interior and exterior. We can change the different bars. So max interior here, maybe we'll go down a little bit so that we'll change these down to 12. And also here, so for the footing portion, we can define each face and all the different definitions. So really easy to lay this out. So anything we do in here, we just say okay, and it is automatically in this mod here. So actually we want 2 layers for our footing dowels, but it's automatically put into the spreadsheet for you. So you can still work with the spreadsheet if that's helpful, but I do think this picture is a really great way to do that as well, to enter the information, especially when you're first starting out. Maybe once you're designed the model a couple of times, you can just quickly change things in the spreadsheet. My interior wall, and what I've done in my interior wall is I removed all my soil pressures and information in here. So it's just going to have no soil on that backside. So there's not going to be any surcharge. There's not going to be any soil information here on the backside. It's just going to be an interior wall. I have reinforcement because it's going to be an actual load-bearing wall interior of my structure, though. So I'm going to say okay, and I'm just going to say okay. And now I can define these interior and exterior retaining walls. So I'm going to click on Draw Retaining Wall and choose maybe 4,000 normal weight. And I'm going to start by drawing my exterior here. If I did not think about doing my definitions before I went in here, I could create a brand new one and just start with that. This new one will allow you to define right there. But I've already gone ahead and thought it through, so I'm going to just use my exterior retaining walls and push play. You just draw retaining walls by clicking those nodes there. And I'm just going to run across the exterior of this building and find these retaining walls. So if I kind of below the shear as we go here. Oops, and I keep going here. And maybe since I did this footings here, I'm going to leave those footings. This might be maybe where the slope changes in my building, and I'm not going to have retaining walls in this portion. So once I put in my retaining walls in those locations, I can also do my interior ones. Oops, wrong icon here. Let me click on that one. So my exterior, I'm going to go to interior, just push apply, and maybe this is going to be here. This little portion of my shear wall here is going to be my interior on this side too. And what you'll notice is that that interior just changes colors. All this is just showing us here that there's two different wall sets. One is gray exterior, one is the interior, which is the purple. So for that, I'm going to just solve this model and do a solution. And I get some results here. First thing we can look at our results are based on our spreadsheets. That's an easy way to look at retaining wall results. And what you see here is footings defined here. So you have your heel, flexural you see, our toe, the toe and the heel you see. So everything looks pretty good in here. Everything is under 1, which is what we want. Wall looks like it's all also very close to getting high ones here, but we are still under the code check of 1 pole. So it looks pretty. If I go over to capacities, it lists out all the different capacities, telling me here the wall capacities as well as the actual footing capacities. And then it gives me the geometry of each one. The steel here tells us a lot more, just a breakdown of what reinforcement was in what, where was in the walls versus the footings, and then the dowel bars. And if we pop stability here, so it looks like we might have some sliding problems here. We've got some issues with sliding. Maybe we should put a key in for some of those walls. I think I had no key in there, but it'll break it down and give us a little bit more information there. And it looks like I have some bearing checks, so I might want to increase some sizes there. Otherwise, my capacities seem to be okay. So another way to view that is also look at your detail report. I can click on there on the detail button and then click on one of those walls. And let's take a quick look here. It does a nice sketch of this retaining wall for me. Shows me a little bit of the information. I've got soil on this one. This is an exterior one, so I have soil showing here. If I scroll down to that, it shows me a load diagram of what loaded it onto the actual the wall as well as the footing. Lots of different loads on this model. If I scroll down, it gives me what we have similar to in footings, and we see kind of a breakdown of the geometry listed out for us, as well as some of the factors that went into it, and then our reinforcement. Scroll down below that, it gives us kind of a nice diagram showing us the different. This is similar to what you would see in a code check information for all other members. You have diagrams of the maximums and minimums. Gives us the code breakdown where you see what was the governing MU, so you have all of that listed for you, the shear details as well as the results for each one. And a lot of almost sometimes what I've noticed, you get a lot of area steel. You have to get your row min. You're trying to meet minimums. So this is a great way to say, okay, did I meet my minimum? And I did in this wall in particular. It looks like I'm exceeding my minimums there. So when I scroll down below that, I see my footing design, and it gives me a breakdown of what happened in the toe versus the heel, and then some of my overturning checks there and sliding checks. So this one looks like I'm a little high on this, but I think that is okay. So we've got that. And then we look at here. I'm going to zoom in a little and grab this wall. So I've got my retaining wall here. This one was my interior wall, and what you'll notice the big difference in this one, I put a little key in that one for just to show how that looked, but there's no much loading on this one because I'm not having that soil pressure. So there's a different loads on this one than you would see in the exterior wall. I'm carrying the loads down the building. I'm not seeing any real moment in shear in this service level because this is just going to be our vertical loading on that. This one was propped, so it was also seeing no overturning or any sliding in this wall. So it's a little different results in that. You can see when we look at the model here, if I look at this in isometric and we turn loads back on, you'll see that those loads get carried right down the retaining wall. So they're coming right there into the wall. So all of my retaining walls, let's see here. On the next and last thing I want to show you is taking this model back into RISA 3D. And I want to take this model into RISAConnection. So a solution present. So assuming our foundation is complete, want to then take, and our RISAFloor and RISA 3D are then complete, we can then take it over to RISAConnection. So using the director button, just like we did over from RISAFloor or RISAFoundation, there's another tab for RISAConnection. Click on that. All of this model takes all of my results from all my beams that I defined, and it'll take it right into RISAConnection. Smattering of different combination of different end conditions to kind of try to pick some of the worst cases. And we can see that here. In particular, I wanted to show you the newest ones that we've added. So braces, if I join real quick and I click on this, it'll expand it. This is my one chevron brace that I defined in my RISA 3D model. And I can see here the different pieces of this chevron brace, and I'm going to click on the 2D view because this is a great way to see it. You can define this connection here in RISA 3D. I just told the program that I was using a chevron type brace, and then it knew what type of members were coming in. So I have a dangle on this, a 5 by 5 by 3. On this, I have a 3.5 by 4 by 4 by 3. So I have the two sides of that chevron coming in. The gusset player is defined here. I've got a 1/2 inch gusset plate, and I can make changes to the geometry in here. I can increase this. It's a great way to make changes. You can just click on the members themselves and adjust them. So maybe 20 inches there. Maybe I want to make this a little bit bigger. For some reason, maybe the geometry is not working out for me, and I need to make this plate a little larger. I can increase that length of that connection to 55. Resize it, and maybe I can change this number here to 22, and it sort of bumps things down. So you can rework that direction. I'm going in to the central point, and you can see that lines up there. That center line is coming in right at the center point of the beam. That's all organized there. But you can also adjust all sorts of stuff like your longitudinal spacing. So the spacing between the bolts, whenever you click on that, it actually highlights there, and I can just type what I want. If I want those to change, maybe tighten that spacing up there for some reason, I can adjust that to 3 inches, and it'll change it. And you'll notice the different pieces are adjusted just by clicking on them. Once you've model here, I'm going to just solve it so we can just see a quick report. This one seems to be failing. If we look at this, it looks like I am having some geometry problems, so it's failing in geometry. But what's really nice about this is that it gives us this this report format that you can expand and understand what was happening in this model further by the code check, but then also by the equation that was used there, and it lists out the equation that is right in the code. So this is a great way to understand your model a little bit farther. I'm going to jump over here to column splices. This is a new one that was added, so you can do a moment column splice or a shear column splice. You can see here, you've got these gusset or plate sections attached to this, so you can adjust any of the different parameters of this, giving it a different thickness. If I want more or less bolts in there, I can define any of this different information. And again, you can see here in dimensional view, this is a great way to view it and adjust things. If things are failing for some reason, we can solve this group here, and it looks like everything seems to pass in here. So if I jump over to my results in here, I can see maybe I'm oversized. I have very little going on in this column, so maybe these is just big for what I need, and then I can start to size this down if I needed to. The other thing let's take a look at, let's go back to our features here, and I jump. So we have added chevron braces, we've added column splice, moment splices, we also added diagonal braces. I'm going to click on that for a second here, and I see the different column splices, and let's jump to one that's 2. So what you can see on this one is I really like this one to show the different angles that are happening and how it's supported here. You have 2 separate connections happening. Well, actually more than 2, but you're in the upper portion connection and then the lower portion of this connection. But there's obviously the connection to the gusset, to the beam, the gusset to the column as the brace comes in, and the reports help you see that. So if you get the report, we have to solve this connection for a second. I'm just going to solve it. And the reports help us break down. Each tab on top tells us what's happening. So right now we're looking at the beam to column connection. If we look at, and this is the top here, that's the beam to column, but then we can look at the top gusset to beam, how that works. So it looks like we still have some geometry failures in there. If I look at the bottom, I can also look at the top gussets. So it breaks down by each single check with a summary at the very first to tell you a little bit more information per connection. If I look back on this two-dimensionally, I can see I can start to maybe adjust that. Okay, so if I have some edge distance, maybe I need to increase this up here. So just click on that 21.45 and adjust it. Maybe it needs to go to 24, for example, and you can rerun the solution. The way that this is organized came from RISA 3D. So I have we look at new features at top here. This is organized by connection. So 3D, it comes in and it groups everything that's similar by connection. So diagonal brace, and every single diagonal brace is a slightly different. Maybe we can adjust things that are on the mass that are the same. So if you click a diagonal brace, you can adjust pieces of that connection if they're similar. Otherwise, you want to drill down to each single connection to adjust that. But what's nice is that once you run the whole project, and I solved the entire project, we can see what worked, what didn't. If there's passing and failing, I can then go back and address each one of those, and then design each better, upsize or downsize. And then I can save the model and take it back to RISA 3D. So save this model, and I want to show you. Once I save the model, I can just pop it here and back into RISA 3D, and automatically this connection design results pops up. It knows the program I was just working on connections in another program. I'm going to send that information. As soon as I push that save button, it then said, okay, that I've been working on the flange plate moments. I've been working on a lot of these different things, and it gives me a nice brief summary of what happened. What was going on there? There's some geometry restrictions we saw there. So that's the problems in this connection. Got some gusset plate restrictions here. So we see failures, some stuff we still need to work on. What's really is that you have a running tally in this program. In RISA 3D, you have it, and you also have it based on its view. So you can see its results graphically. So I can see that I'll still work on that connection. There's some issues there. This one looks like it's actually failing a little, 1.7, so I need to work on that one. And then I can also still view it based on connection rule. So if I look in and zoom in a little closer, I can see, okay, that was the end plate, this was the flange plate, and I can see that there was the diagonal braces here. So all this stuff can be just, you can see it right inside of, if you double click on a member too, you can see its reconnection, whatever its connections rules will put in the program. We talked about that in RISA. But just like in RISAFloor, there's a connection rules spreadsheet, and you can define how things are connected inside of that. So all of that displayed right inside of the model in RISA 3D. So the programs, as I discussed from the start, all communicate with together, and I tied one model together so you can see all the features in one. But obviously, you can just use single of each single one and play around with the features, maybe just in RISA 3D or just in RISAFloor. But it is nice to see how they all are integrated and how they all work together too. So let me pop back in here. I was mention any additional resources at this point where I showed a variety of different features. We went fast with lots of different programs, so if you have more questions, definitely refer to the release notes. We list out all of the different features on there. We also do RISA News. We talk about the new features and how they work. So if you have questions, that's a great resource. We try to write articles on how to apply the new features. Obviously, always support at RISA.com is a good resource. And then our users guides. We walk through tutorials when we have new features that might get more complex. We try to put together a user's guide or a tutorial. So you see some new wall panel tutorials